Okay, today we're looking at section 6.6, methods of savings. So we'll first look at different types of savings account and proceed to discuss the various types of investments. There is some overlap, but we'll try to differentiate among these financial instruments. Saving money should be a goal of every adult, but it can also be a difficult goal to obtain. So there are at least three types of savings account: traditional savings account, certificates of deposits, and money market accounts. All three main savings account vehicles. Savings account is probably the most well-known type of investment. For many people, it is their first experience with a bank. Savings account is a deposit account held at a bank or other financial institution which bears some interest on the deposited money. Savings accounts are intended as a place to save money for emergencies or to achieve short-term goals. They typically pay a low interest rate, but there's virtually no risk involved, and they're insured by the FDIC for up to $250,000. Savings accounts have some strengths, highly flexible. Generally, there are no limitation on the number of withdrawals allowed and no limit on how much you can deposit. It is not unusual, however, that a savings account will have a minimum balance for the bank to pay maintenance costs. If your account should dip below the minimum, there are usually fees attached. There are some weaknesses to savings accounts. Primarily, it's because savings accounts earn very low interest rates. This means they are not the best way to grow your money. Experts, though, recommend keeping a savings account balance to cover 3 to 6 months of living expenses in case you should lose your job or have a sudden medical expense or emergency. Around tax time, you'll receive a 1099 INT form stating the amount of interest earned on your savings, which is the amount that must be reported when you file your tax return. 1099 form is a tax form that reports earnings that do not come from your employer, including interest earned on savings account. These 1099 forms have the suffix INT to indicate that the income is interest income. Savings accounts earn interest, and those earnings can be found using the interest formulas from previous sections. Final value of these accounts is sometimes called the future value of the account. Brian deposits $5,600 in a savings account that yields 1.23% interest, compounded annually. If he leaves that deposit in the bank and adds nothing new to the account, what will the account be worth in 5 years? So we have the amount equals the principal times 1 plus R over N to the NT. In this case, N is simply 1. So we're really looking at 5,600 times 1 plus 0.0123 to the 5th power, which is 5,600 times 1.0123 to the 5th power. So 1.0123 to the 5th power gives us 5,600 times 1.06461. 1.06461 times 5,600 equals $5,961.82. So not a whole lot of interest, but a little bit with no risk involved. Certificates of deposits differ from savings account in a few ways. First, the investment lasts for a fixed period of time, agreed to when the money is invested in the CD. These time periods often range from 6 months to 5 years. Money from the CD cannot be withdrawn without penalty until the investment period is up. Also, money cannot be added to an existing CD. Certificates of deposit have features similar to the savings account. They are insured by the FDIC. They are entirely safe. They do, though, offer a better interest rate. The trade-off is that once the money is invested in a CD, that money is unavailable till the period ends. So let's look at Denise deposits $3,500 in a CD bearing 2.23% interest compounded quarterly for 3 years. How much will Denise's CD be worth after those 3 years? So here we're compounded quarterly. So our amount is equal to our principal times 1 plus R over N to the NT. Our principal is 3,500 times 1 plus our interest rate in decimal form, 0.023, nope, 2 twos, 0.0223, and it's compounded 4 times. And then we have 4 times 3. So we're looking at 0.0223 divided by 4. Then we're going to add that to 1. And I get 3,500 times 1.005575. And we're going to raise that to the 12th power. So I end up with 3,500 times 1.06899. So it's 3,500 times 1.06899, and we get $3,741.47. So $241 in interest. That's not too bad. Okay, lastly is a money market account. Similar to a savings account, except the number of transactions, withdrawals, and transfers is generally limited to 6 each month. So you can take money out, but not as many times as you want. Money market accounts typically have a minimum balance that must be maintained. If the balance in the account drops below the minimum, there is likely to be a penalty. Money market accounts offer the flexibility of checks and ATM cards. Finally, the interest rate on a money market account is typically higher than that on a savings account. So Chuck opens a money market account and deposits $8,500 in the account. It bears 1.83% interest, compounded quarterly. If he leaves and makes no other, leaves the money there and makes no other transaction on the account, how much will he have after 3 years? So again, the amount equals the principal times 1 plus R over N to the NT. So in this case, our principal is 8,500. 1 plus our R in decimal is 0.0183 quarterly, so N equals 4 to the 4 times 3. So here I have 8,500 times 0.0183 divided by 4. And we're going to add that to 1 to give us 1.004575. And we want to take that to the 12th power. And we get 8,500 times 1.05630. So 1.05630 times 8,500, and we end up with $8,978.55. So almost $500 for just leaving that money sitting there. If we want to compare the profitability of different investments, like savings accounts versus other investment tools, we need a measure that evens the playing field. Such a measure is return on investment. The return on investment, often denoted ROI, is the percent difference between the initial investment, P, the principal, and the final value of the investment, FV. So the return on investment is FV minus P over P, expressed as a percentage. So the amount of $13,000 is invested in a savings account. After 10 years, the account has $15,250. Find the return on investment for this account. So ROI is equal to future value minus principal divided by principal. So 15,250 minus 13,000 divided by 13,000. This is 2,250 divided by 13,000. So 2250 divided by 13,000. And then multiply that. So this is 0.173. And as a percentage, it's 17.3% return on investment. The amount of $6,500 is deposited in a money market account. After 7 years, the account has $7,358. Find the return on investment. So again, a return on investment is equal to the future value of $7,358 minus the principal of $6,500 over the principal. So here I have 858 over 6,500. 858 divided by 6,500. Then multiply that by, well, that's 0.132, which is 13.2%. Okay, that brings us to annuities as savings. People often open savings account or open accounts that allow them to add deposits or payments to the account at regular intervals. This agrees with a 50-30-20 budget philosophy where some income is saved every month. When a deposit is made at the end of each compounding period, such a savings account is called an ordinary annuity. The formula for the future value of an ordinary annuity is the payment times 1 plus the rate, 1 plus R over N to the N times T minus 1, all over R divided by N, where FV is the future value, payment is the payment, R is the annual interest rate in decimal form, N is the number of compoundings per year, and T is the number of years. It is important to note that the number of deposits per year and the number of periods per year are the same. So Kelly invests $525 every third month. So that would be quarterly. At the end of the compounding period, into an account bearing 3.89% interest compounded quarterly. So there it is for us. How much will be in the account after 15 years? So we have future value equals payment 525 times 1 plus R 0.0389 over N, which is 4 in this case, to the N times T, which is 4 times 15. Then when we're done with that, we're going to subtract 1. And then this is all going to be over 0.0389 divided by 4. So let's do that part here. 0.0389 divided by 4. Okay, so now I have 525 times 1.009725 to the 4 times 15 60th power minus 1. And all of this is done before we multiply. And this is over 0.009725. So I have 1.009725 to the 60th power. Then I'm going to subtract 1 from that, minus 1. And I have $525 times 0.7873 over 0.009725. So we multiply 525 times 0.07873, then divide by 0.009725, and we have a mistake. Okay, let's see. 0.0389 divided by 4 plus 1. Well, that's 0.09725. Oh, I think I know where I went wrong. Let's go back to this. 525 times 0.7873 divided by 0.009725. There we go. And we end up with $42,502.06. Gotta watch those zeros in them decimals. Okay, so we have BEMNet saves $280 per month in a savings account bearing 0.311 interest compounded monthly. After 20 years, how much does BEMNet have? So again, we start out with a future value equals 280 times 1 plus R, which is 0.0311 divided by 12 to the 12 times 20 minus 1. And this is all over 0.0311 divided by 12. So we'll do that part first. 0.0311 divided by 12. I'm going to go ahead and add 1 to it. So I have it equals my 280 times 1.002592, and that's going to be to the 240th power. Then I'm going to subtract 1 from that. And I'm dividing this all by 0.002592. So 1.002592 to the 240th power. Then subtract 1 from it. And I end up with 280 times 0.86130 over 0.002592. So 0.86130 divided by 0.002592 times 280, and we get $93,041.67. Okay, so that brings us to computing payments to reach a goal. So now what we want to know is we have a goal. We know how much we want. I'm saving money for a car or a house or whatever. So I know how much money I need to have at the end. What I'm trying to figure out is how much money I need to put in each period in order to reach that goal in how many years. So the formula for this is payment is equal to the future value times R divided by N divided by 1 plus R divided by N to the N minus 1. We just manipulated the previous formula. So let's look at this and see what we can do here. Let's see, let's rewrite this here so we don't lose it. The payment is equal to the future value times R over N over 1 plus R over N. And this should be to the NT minus 1. So Xion decides to put new siding on her house. She finds that it'll cost about $27,800. She decides to begin saving for the purchase so that she doesn't take on a debt to side the house. How much can Xion, or how much would Xion need to deposit each quarter in an ordinary annuity that yields 5.16 interest compounded quarterly again for 5 years? So the payment equal to the future value, which in this case is 27,800 times the interest rate, which in this case is 0.0516 divided by N, which is the number of compounding periods, which is 4, all over 1 plus interest rate 0.0516 divided by 4 to the N, which is 4 times T, which is 5, and we're going to subtract that 1. So what do we have here? 0.0516 divided by 4. That gives me 27,800 times 0.012825. And here I'm just going to add my 1 to it. So I have 1.012825. And 4 times 5 is to the 20th power, subtracting 1. So let's take that to the 20th power, subtract 1. And my new denominator is 0.29029. Then find out 27,800 times 0.012825. And that is 356.535. So we'll divide that by 0.29029. And we get $1,228.20. And that finishes section 6.6.